Alright, so this is homework problem 4.3, problem 223a. So we're going to be using Laplace transforms to solve this ordinary differential equation. So first step is going to be to take the Laplace transform. So we're going to use this general form of the transform and then apply it to our ODE. So that's going to go to s squared x of s minus s x of 0 minus x dot of 0 plus c, which is going to be 8 s x of s minus x of 0 plus k, which is going to be 15 x of s equals, and then f of s, since this is a constant, it's going to be 30 over s. So the next step is going to be solving for x of s. So here we're going to look at x of 0 is 10 according to our initial condition, x dot of 0 is 4, and then x of 0 over here is also 10. So writing this all out, you're going to have s squared plus 8s plus 15 times x of s equals 30 over s plus 10s plus 4 plus 8 times 10, which equals 30 over s plus 10s plus 84. So that was just simplifying this equation up here. So solving for x of s, it's going to be the characteristic equation, which is this, 10s plus 30 over s plus 84 all over, the end result all over the characteristic equation, which is s squared plus 8s plus 15. So that's going to be the characteristic equation. And then simplifying that further down, we want to get this s in the denominator. So it'll be 10s squared plus 30 plus 84s all over s, and then if you factor this out, you get s plus 3, s plus 5. Then you'll have your constant over your first denominator term plus constant 2 over your second denominator term plus constant 3 over your third denominator term. So then we're going to solve for these three constants, and I'm going to use the limit method. So C1 equals limit as s goes to -3, because that's the negative Ri. And then you'll have your equation on top, 10s squared plus 30 plus 84s all over the two denominators that you're not looking at, so it'll be s times s plus 5. And if you plug in -3 for s in all these terms, you get C1 is 22. Similarly for C2, we'll do the limit as s goes to -5, because that's the negative Ri term down here. Then you'll have your numerator again, 10s squared plus 30 plus 84s all over, and then the two terms that you're not looking at, s times s plus 3. And if you plug in -5 for all the s terms, you're going to get -14 as C2. And then following for C3, you have limit as s goes to 0, because it's just an s down here. And then you have your numerator, 10s squared plus 30 plus 84s all over the two terms you're not looking at, so s plus 3 times s plus 5. And if you plug in 0 for all the s terms, you're going to get C3 equals 2. So next step is going to be taking the inverse Laplace transform. So you're going to get x of t is the inverse transform of x of s, which is the reverse transform of, if you're going to plug in your constants here, you're going to have C1 is 22 all over s plus 3 minus 14 all over s plus 5 plus 2 over s equals, and then for this you're going to want to use your inverse Laplace transform table. So for this first term, 22s plus 3, you're going to look at this one because you have s plus 3 and you have a constant on top. So that will convert to 22e and then the negative 3t. And then you're going to use the similar equation here, minus 14e to the negative 5t. And then since this is a constant, you're going to look at this equation. So it's just going to be your u of s of t. So it's going to be plus 2, which is your constant, us of t.